This tutorial is a brief summary of the gas laws, and we've done 3 labs that addressed all 3 gas laws. And our first lab addressed the pressure-volume relationship found in gases, and when you graphed your data, you had a curve that looks like this, and you also established an equation for the pressure-volume relationship, which was pressure times volume equals a constant K. And then this can be used to derive Boyle's law, which is P1 times V1 equals P2 times V2. So in this gas law, we have an inverse relationship between pressure and volume. And remember, when an inverse relationship occurs, when one variable goes up, the other variable goes down. In our second lab, we investigated pressure-temperature relationships in gases. In your graph data, had a curve that looks like this, and you derived an equation like this. The constant K is derived by equals pressure divided by temperature, and we can get Gay-Lussac's law from this. P1 over T1 equals P2 over T2. This is a direct relationship between pressure and temperature. In our third lab, we looked at volume and temperature relationships. Again, you derived a curve like this. We have a direct relationship between volume and temperature, and the constant K equals volume divided by temperature. And we can get Charles's law from this. V1 over T1 equals V2 over T2. Again, this is a direct relationship between volume and temperature. When we combine all 3 gas laws together, we get the combined gas law. And this is P1 times V1 over T1 equals P2 times V2 over T2. This is the only gas law equation you really need to know, because we can derive all of the other 3 gas laws from it. So if we think about this, if temperature is held constant, that means then T1 equals T2, and T1 and T2 would cancel each other out, and we'd be left with P1 times V1 equals P2 times V2, which is Boyle's law. So if we held temperature constant, we get Boyle's law. If we hold pressure constant, then P1 equals P2, and they would cancel out, and we'd be left with V1 over T1 equals V2 over T2, and this is Charles's law. So when pressure is held constant, we get Charles's law. And if volume is held constant, then V1 equals V2, and they will cancel out of the equation, and we're left with P1 over T1 equals P2 over T2, and this is Gay-Lussac's law. So we can derive all 3 gas laws from the combined gas law. So all you need to know is that combined gas law. So let's think about solving equations with the combined gas law. And this is really just simple algebra problems. So when you're given a problem, what you really should be doing is writing down what each of your variables represent from reading the word problem and then solving for the correct variable. I want you to be able to write an equation solving for the appropriate variable before you plug in any values. So for instance, let's say we have to solve for V2. That means we need to isolate V2. The best thing that you should do here, the easiest thing to do, is do the old cross multiply. Take this combined gas law and do the old cross multiply. When you do that, you're left with P1 times V1 times T2 equals T1 times P2 over V2. Now it's going to be really easy to solve for whatever variable you need. So if we're solving for V2, then we need to divide both sides by T1 over P2. So that will cancel T1 and P2 out of both sides. So we're left with this equation equals V2. Then you can plug in all your variables. Okay. Likewise, here's our combined gas law again. Do the old cross multiply. P1 times V1 times T2 equals P2 times V2 times T1. And then let's say we want to solve for T2. So we're going to solve for T2. In this case, then, we want to divide both sides by P1 times V1. So over here, they're going to cancel out. So we're left with T2 equals P2 times V2 times T1 over P1 times V1. Then you can plug in all your variables. Don't forget that temperature always has to be in Kelvin. Why? Because Kelvin temperature is directly proportional to average kinetic energy of gas particles. Kelvin temperature is directly proportional to average kinetic energy of gas particles. So you have to convert your temperatures to Kelvin. Celsius to Kelvin, what do? You add 273. So don't forget to convert your temperatures before you use your gas laws.